For AI, the question that I like to ask myself all the time, that was once asked to me, is what would you do if all the jobs paid the same? And there's something in your mind, and that's your passion.
Welcome back to the Exploding Podcast. My name is Teja, and I'm so grateful that you are here. I'm genuinely so proud of our incredible community growing across the world in India, UK, Canada, and Philippines. Thank you so much for each and every single one of you coming back every time to learn, execute, and exploit. And those reviews of you in my inbox energizes me to take you deeper and makes me more responsible to find and bring more amazing guests that you love every single time. So getting into today's episode, I'm always excited for the guest, but I'm especially excited when the guest had a personal impact on me and my learnings. As you already know, he is none other than Luis Serrano. Luis is a data scientist, quantum AI research scientist, an incredible teacher, YouTuber, and an amazing author. In the past, Luis had worked for Apple and Google, where he was on creating and maintaining the YouTube recommendation algorithms. He was a content lead of AI at Udacity as well. He creates and maintains the Serrano.Academy, which aims to make the math and machine learning easy for every single data science aspirants in the world. Before his life into technology, he was a research mathematician and a PhD person from University of Michigan. On top of all of that, he's the author of Grokking Machine Learning. Currently, Luis is a quantum AI research scientist at Zapata Computing. I hope you're as excited as me to move forward. Let's welcome Luis Serrano. Thank you so much for joining us, Luis. I'm really excited that you are here.
Thank you, Teja. It's an honor to be here. Thank you. Thank you for the invitation. I'm very excited too.
And there is one more thing that I couldn't resist sharing with our listeners. On another day, I was a mentor and organizer at PyCon India 2019. Someone actually approached me and said, I'm trying to understand the math behind the various machine learning models. What would be your advice to learn them intuitively? I just replied to check them out, the machine learning nano degree taught by Luis Serrano in Udacity. And that's it. He's such an incredible teacher and one of my best teachers in data science. Even if you have a similar question right now, Luis is going to help you to enhance your learning. Thank you so much for making this happen, Luis. It really means a lot to me.
Thank you. Thank you for the invitation. I'm very excited too.
Yeah. So let's start with the opening question. You have been through a lot of phases as a student, teacher, data scientist, software engineer, author, and YouTuber. Now we are quantum engineer, right? So I believe there is one among this that made you feel like doing more with a motive energy every single day. What was that one phase in your journey?
Yeah, definitely. I mean, they're all very special because they all teach me something different. You know, researching teaches you different skills than teaching that teach you different skills than programming. So that's why I like to switch things around to really teach myself everything. But I mean, certainly if I have to pick one, it's teacher. The teacher in me is sort of the strongest part of me.
Cool.
And I really enjoy just breaking things down. Showing them to students, and the process of seeing the students learn and improve and seeing their stories is something that's very inspiring to me.
Cool. And you are currently AI research into the quantum computing. So what is that all about? And what sort of work you do at Zapata Computing as a quantum AI research scientist?
Yeah, that's very interesting stuff. My latest passion is quantum AI, quantum computing and quantum AI. And it's very fascinating. I mean, to make a long story short, regular computers are just a bunch of switches, right? On-off switches, which have like basically bits that can be 1 or 0. But quantum computers are much more than that, right? Because the qubit can take every value from 0 to 1, and actually in many different ways. So it's actually much more complex than just a superposition between 0 and 1. And with that, if you make computers with that, I mean, if you make these qubits interact, they interact with each other. There's things like entanglement, where one qubit influences another one. So if you use that for computing, it can be very powerful, right?
Yeah.
And there are some difficulties, like you can't really observe them. If the qubit has a superposition of 1 and 0, but the moment you observe it makes a decision, and it goes as 1 or 0, so you lose a lot of information. So you have to, before observing them, just manipulate them a lot. So it's very powerful, and also has higher levels of complexity. But for AI, it can really help, right? Like sometimes you have bottlenecks in AI. Like in general, for algorithms, you can make them much faster using quantum computing, and for AI is not an exception. So you can take existing algorithms and see difficulties that they have, whether it is in speed or in how they look at the data, or how, for example, generating data is much easier. Well, it's not much easier, but it's doable by just observing particles, right?
Yeah.
So it improves AI a lot, and what we're figuring out is how. So we're looking at many problems existing. My work consists a lot of looking at existing algorithms in AI and saying, okay, how could I make this quantum, right?
Yeah.
And looking at problems from industry a lot. A lot of problems. It's like, okay, there's this difficulty in this algorithm when this company is trying to do this, so let's try to speed it up with quantum. So it's been a lot of fun.
Awesome. That's actually great. And also, when I gave you multiple phases of your life, just saying it out there, like a student, teacher, data scientist, software engineer, author, and quantum engineer, these all. So you got to choose teaching, right? And I got to know just now that you're so passionate about teaching then. Possibly that would be the thing.
Yeah.
And when did your passion for teaching started then?
Yeah, I mean, I think it was always there. I always enjoyed explaining. I always enjoyed, breaking things down and sort of telling a story. Like, I feel like that's just a nice way to portray things. And I think my teaching comes with how slow I am to understand things. I think when I am in lectures, I normally get lost. Like in high school, university, I'm always just a few steps behind, and in working and everything, it always takes me a while, and the reason is that I have to understand things very well. Sometimes people can work with things that they sort of understand them and they start working with them and doing wonders. I don't have that skill. I need to understand them very well. So I found myself going over lectures repeatedly, in university, just going over the lectures. And really trying to understand everything much better, and explain it to myself the way a 5-year-old would understand it, and then I could do things with it. So I always thought it was a difficulty, right?
Yeah.
And research, in research, it was, it took me a long time. Like, people were faster than me, but then when I started giving talks and teaching and during my academic career, I realized that was much easier for me. That I could explain things and my classes went well and my talks went very well. And some of my friends who were way faster than me doing research and who just taught in high level much better, they had a hard time explaining. They would explain everything in such high level that nobody would understand. So I always thought, okay, well, I never connected that my slow thinking was the same as my easiness at explaining. So when those came together, then I really decided, like, okay, I'm always gonna be teaching.
Yeah, possibly. One good thing that I got to know when I was going through your Udacity courses, when you were instructing the machine learning things. So when I'm being through that, you can say something to someone, they forget. Okay, you just show them, they just remember, right? So once you make them involve into something, they would never ever forget that.
Exactly.
Right? So that's the thing that I found from your teaching, from your YouTube videos, or however. So, I mean, one memorable thing that I got from your lectures is the Markov chains, the YouTube video that you have on a Markov chains, a Markov model. That's amazing. I've been through a lot of research I've been doing, and I couldn't able to understand that. But
thank you.
Personally, I felt there is one, and I couldn't able to like it more than one time. Believe it or not.
Thank you. Very kind of you. Thank you.
Yeah, so in the same way, I know about your work, Grokking Machine Learning. I'm pretty excited to know about it.
Yeah, no, I'm enjoying it a lot. I'm enjoying the writing a lot, and it's almost done. So one thing I like is two things, right? Like you mentioned doing things, and that you show how to do something.
Yeah.
And I also like narrative. I think stories are very important,
Yeah.
How many times do we read a fiction book versus how many times do we read a book with facts, or how many times we watch a movie versus a documentary, right? Like I watch a lot of movies, even though they're not, they're fake, right? There's not stuff that existed.
Yeah, it was fun doing it.
Yeah, it's fun, right? Because people like stories. We're engineered to or the way we are and we grew up is we like listening to stories,
yeah,
right? More than we like a list of facts. When we realize the facts, like we just get tired at the beginning, whereas you cannot stop a good story at the beginning. You have to finish it, right? So that's sort of my way of teaching. So in this book, I try to tell stories. I mean, if I could call it short stories in machine learning, I would call that. But it's really like I try to look at every algorithm and do two things. Let me think of the simplest example that I can come up with, and that explains the algorithm. Like what happened with hidden Markov models, right? I thought about an example of two friends.
Yeah.
One of them is the weather, and the other one is happy or sad based on the weather, and the one's trying to find out if the other one's happy, and the story gets better because suddenly like there's a complication and they can't talk too much, so they have to send a signal, and so like I try to tell the story of each algorithm like that. So there are stories about aliens in a planet that you have to figure out if they're hostile or happy, and there's another like I try to have a narrative. So that's what I do, and then that's what the book is about, and each chapter is an algorithm in supervised learning. I only cover supervised learning, so linear regression, logistic regression, decision trees, neural network, SVMs, ensemble methods, and each one has I want to make it so that everybody can understand, because I think everybody can understand machine learning. So the math requirements are very few. You need to know some kind of high school math, but anything I explain it with examples. So even things like slope and intercept, that gets explained in the book. Like there's no very little prior knowledge.
Yeah.
And also there's programming. I think there's I have code in Python, and sometimes I use a package, but some other times I actually, the simple algorithms, we code them by hand. It's not something people need to do in life, but it's something that you need to do once, right? Like how we all did long division once. We don't do it now every time, but so it's basically that, and I'm enjoying the process a lot. It's almost done, but it can be found online.
So your book is full of machine learning with stories, and also stories with full of machine learning.
Exactly.
So
that's
possibly.
it. That's it. Yeah.
Great, and I'll be adding the links in the description of your book. So if the people feel like I'm going to read it, so they can head up to the description and go check it out. I highly recommend it to do that as well.
Yes, absolutely. There's a link there to take a look at the book, and there is also a discount code that that they've given me for this particular podcast, and there's also 5 free ebooks to give away. So I'll let you decide how to give them away to your listeners.
Awesome. Thank you so much, Luis. It's really, really means a lot. So I'll take the responsibility to make it to reach the people that they deserve and who really love your work. Awesome. Okay.
Thank you.
So I have this question for you in my mind from the beginning of the podcast. So till my 10th grade, I was in a delusion that math is all about formulae, and I used to solve a lot of problems, but I never felt them connected to me, and those numbers never used to communicate with my brain. Okay, how was your thinking at the time?
Oh, absolutely, the exact same thing. I was very bad at math, actually. Until grade 8, I used to fail math all the time, and things like the quadratic formula, or things like the slope and the y-intercept, and just algebra, geometry, they were so difficult for me. They were so difficult because they were formulas, right? Like they were, I couldn't really see. As you said, they didn't really speak to me.
Yeah.
But there's something that I loved, which was puzzles. I really liked solving puzzles, little games. So I really liked playing games and solving, riddles and things like that. But I never thought too much of it. And at some point, I realized they were the same thing. It's actually funny. As I was failing in math, I started doing well in mathematical competitions, in mathematical Olympiads. And that was a bit of a contradiction. Like, why is the kid failing math, winning at the math Olympiads? But it was very clear to me, like, because those were puzzles, right? Like, and so when I went they took us to trainings for these math Olympiads, and that's when I really fell in love with math, because they show you how math is, in terms of concepts and basically puzzles. Like, it wasn't that many formulas, and that's why I learned that the formulas are really just a language. They're not the math behind. In the same way then when you look at music, right? Like, the music is not what you write. The music that you write with the scales and everything, that's not the music. That's a language that you use to express it.
Totally.
And if you look at those, then maybe it's confusing, right? But
Yeah.
if you hear a song, it's not confusing. It's a song, right? We learn to sing them when we're small.
Yeah.
So I think of math like that. We learn those fun concepts in a way that's, without the language, without the formulas. And we use the formulas to communicate them, but we shouldn't, we shouldn't see math like that. And I'm sad that education has taken us in a path that makes us think that math is formulas, because it's not.
Totally. It was an amazing comparison that you made with the music and the mathematics. That actually makes a lot of sense, and that feels so similar. That's where I actually understood just now. When you try teaching someone about something, subconsciously we create a pattern or a unique approach of communicating intuitively to others, right? So what is your approach that makes the subject so valid and vivid and clear to the others?
Yeah, it's actually a lot of fun, and it takes a long time. What you see is the final product of, could be months or maybe years.
Yeah.
I'm constantly trying to learn a few different things. It comes from, sometimes from work. I need to understand a certain particular thing, like a certain, at some point, neural networks, for example. I had to start understanding what they were. And it starts by the thing not speaking to me, because it's, I see it and maybe I can even implement it, but I don't fully understand how they work. So I start making a little example. Like I say, okay, what's the smallest example that captures the entire complexity of this? So I draw something with maybe 2 nodes or a few data points, and just draw it, and I scribble and I write the formulas and try to remove the formulas, right? I try to say, okay, the moment I can remove these formulas and make them little colors or cats and dogs or something, then I understand it.
Yeah.
Right.
Yeah.
And so I look at things for a long time. I many times just watch other videos and read from different sources. And I just look at it. I try to explain it to people that don't know math. I try to go, hey, let me tell you a story in a napkin. And sometimes my friends are sick of me just like always bringing out a napkin. I try my mom and my family and everybody. And then sometimes there are clicks. Like sometimes I'm like, oh, okay, something just clicked. I think there's an example with a few people that are in the situation, and And a few of those clicks, and eventually I get a clear explanation in my head, and then it stays forever. Then by that time I'm like, okay, now that every time I think of a neural network, or every time I think of a hidden Markov model, I'm just gonna think of this example, and then I'll never forget it. Because if I try to remember the formula, I guarantee you I'll forget it the next day. So yeah, it's a fun approach, and it's a personal approach I take to understanding things, and I'm happy that I can share it with others, and that people get benefit from sort of that same approach. Yeah, and making a video is a big part of that approach. Like when I start making the video, many times I don't understand, and I redo it several times until the last version. It's like, I finally got something. Yeah.
And I know that personally from all of your examples, you take the cats and the dogs, and from the grumpy, happy, and everything. I know I've been listening to all of them. That's actually makes a lot of intuition. And I can say you one thing, that you're really, really good at telling the stories.
Thank you.
I can say you that. So you have been so far teaching all of this with various approaches and various methodologies, telling stories in the universities and online, everywhere. So, but when you go for university specifically and you teach the students, so what is the one thing that you feel like lacking in the current education system there?
Yeah, I mean there are several, right? There are great things about the university, which is the fact that you talk to a person, the fact that you there's a community and everything. But there are certainly some things that are lacking, and that I think we can enhance with technology. Mainly, you said one, but I'll quickly say 3, and then I'll elaborate on one. But one is reach, which is basically you want to get to everybody, right? Like you if you can teach 20 privileged people, but the same lecture can help with billions of people around the world, and we should be able to bring every education to everybody, right?
Yeah.
No matter what their socioeconomic status is, where they live. how old they are, what situation they are. Education should reach everybody, so reach is definitely one. Another would be interactivity, right? Because when I sit, and that I think is the principal one. Like when I sit in a lecture, I am the most passive that I can be. I'm sitting down, I'm looking up, I'm quiet, and I'm just listening. That's not how most people learn. At least that's not how I learn. That's when I struggle in classes because of that, right? I like to be doing things, interacting, building something, or maybe explaining to someone else or talking to someone, and and we have very little of that because lectures are very passive, and they're just the same that they used to be 1,000 years ago, right? Like somebody just stands and talks to others. It's like we can do better, right?
Yeah.
And the last one was personalization, because we all have a different way to learn.
Yeah.
Right? You learn a different way than I do, and someone else does in a different way. But the model is standard for everybody, and so it only benefits one type of student. So we need to do something. If we can personalize, YouTube and Netflix recommendations and everything, we should be able to personalize education and give everybody their own path based on their way of learning and their goals and everything. So in short, I said 3: reach, interactivity, and personalization.
Totally, yeah. That absolutely answered the question, and I got to know now. So the one thing that I really, really love here, the reach and the interactivity that you made, right? That's totally awesome. And so I know that you moved from the university to Google for learning and for the product development, right? So when you had this shift from a mathematics researcher to a data scientist, which means you jumped from the limitless theories with proofs to a real-time application development that you could serve billions, right?
Yeah.
So what are those challenges that you have personally faced when you moved from academics theory to practical industry? And how far the math from the theory differs from the math from the production level product development?
Yeah, great question. There's definitely a lot of differences and some similarities which help a lot. But basically in math, you have to prove everything. The pinnacle of things is proving. When you prove something, you're done, right? Like when you have an argument that shows that for every single one of the cases this is true, then you're done. But in industry, it's very different, right? You don't need to hit all the cases. You need to hit the majority, and fast. So all of a sudden, your brain switches from proving to making things work well and run fast. Most of the time, you may have sometimes it doesn't, but that doesn't really matter. So to me, that was a big shift. But actually, there's a core among the two of them that has helped, because when I was in math, proofs never spoke to me fully 100%. I always try to understand things better. So that's why even in math, I was always trying to do things in an example. And many times I worked out an example and I'm like, oh, cool, this is true. And then I would conjecture something, but then, it wasn't true because I had to prove it, right? I hadn't proved it. So when it comes to, I think the core of those two things, of the proving and the implementing, inside there's a level of sort of, grasping a concept and being able to understand it and build something with it that is kind of true to both. But yeah, definitely the challenge was making things fast, and the technical challenges. Programming to me came later in life, so it was difficult to write programs in scale. I think to me when I started Google, it was coming from like writing little programs for my work that would work in a small case to like doing something large scale was a big challenge. It was a lot of fun to learn, but it was a big challenge.
Super. On top of that, when you joined Google and then moved to Udacity and then to Apple, what are those 3 biggest things that you got an opportunity to work with them? Just like one for each company, what would you pick from them?
Great question. Yeah, at Google, definitely the programming in large scale. I mean, I think cool. that was a big thing that I had to learn there. At Udacity, it was, I had an experience teaching in university, but teaching online was a completely different monster, because it was when the students are not in front of you. You teach in front of a camera, you don't see their faces, you don't know and interact. Then you see a lot of data, right? You see when they when they left, when they started, when they came back, how they answered this. So changing from the data of like looking at faces and facial interaction to looking at data was actually very, very interesting, and that's something I learned there. And at Apple, I think I learned to combine them, right? Because I had the teaching experience and the coding experience, but this time I had to talk to, teach internally, and so I had to be tied with the products and talk to people internally and give sort of consulting, and so I sort of tied them together. I got to have a higher level of involvement. At Google, I was very low level. I was just doing the production code, but at Apple, I had a bit more of a high level on how, telling more how the models worked, etc. So that was fun. So yeah.
Great. I think you create beautiful journeys no matter where you go. As you are in the industry for years, what I would like to ask you now is, rather than knowing how to start machine learning, instead I want you to say about how to not start machine learning. Because often when we know about what would go wrong, our brain infuses not to be on it, right?
Great question. Yeah, I may answer something that's a little paradoxical, but it's you kind of have to develop your own path. Everybody's path is different, and you feel kind of guilty. Things are very helpful, right? Like chronicles of other people learning are very helpful, and there's a lot of people who put videos and blog posts of how I learned machine learning, and it's very useful resources, right? So I recommend look at those, but I also recommend don't follow them that closely because if you go on a blog and it says this is how I learned machine learning, I first read this entire book, and then you get to the chapter 1 and then like, oh, I'm lost, and then you feel guilty that you're not following the path of this person, right? It's not because you just won't be able to achieve what they achieved. It's just that you have a different way of learning, a different path. So looking at those for advice are great, but also knowing that you don't have to follow them closely. You just have to make your own path. So maybe try this from one, this from another one. I jumped around a lot. I tend to do that. My brain is a little all over the place, and ADD. So I think I tend to I jumped from one course to another one. I read a little bit of this. I tried a little bit of this. I tried this notebook. So it's a little all over the place. And some people are more structured. They just go for an entire course from beginning to end. They just go for an entire book from beginning to end. Yeah. So basically, just see who you are, form your own approach, and don't feel guilty for doing your own thing. That's the only no with that is don't feel guilty.
I totally get that. And getting into this one more specifically, few people would say to start with programming in the first and you move ahead. On the other hand, few people would recommend to start with math in the first place and you move forward. So what do you say about it?
Yeah, I mean, in the same way that everybody has their way of learning, everybody has their path, their story of how they got into machine learning, right? And their previous knowledge. I came from math, from years of doing just pure math because I didn't plan it. I wanted to be a mathematician, and then I decided I wanted to be a data scientist. So I didn't come in the traditional way, but many people don't come the traditional way. You definitely need both the math intuition and the programming. And so I had to, my path was I need to learn a lot of programming. But other people's path had the programming and they need to learn a lot of math, or other people. But I think no matter where you come from, you can do machine learning. I've had coworkers who come from all walks of life, from every single career path. Somebody can come into machine learning, because if you think about it, what you're doing is you want to teach a computer to think like a human, right? And it's all humans, not like a mathematician or a programmer, but like any kind of human, right? So any discipline teaches you something about how humans operate. And if you have that frame of mind, if you think that way and you have that discipline in your head, you come in thinking like that, and you can improve machine learning a lot. So diversity is very important.
Yeah.
In for that. And I mean, I think anybody who comes with their own strength can join data science. Yeah.
Cool. That's amazing. I'm kind of curious to know what makes people surprised when they know something about you.
Oh, when they know something, I think So people think I'm smarter than I am. And then they meet me and they're like, oh. No, I mean, I think in some way...
I don't believe that.
No, here's the thing. People think I'm the stereotypical fast sort of machine learning professional slash scientist that goes, this, that, formula. And then they talk to me and then I start asking simple questions about everything. It's like, okay, what about the for n equals 2? Okay, what about the first line of this paper? Sorry, I'm not sure if I understand this. And then I go to page 1 in the book and I stick to page 1 and I'm like, okay, what about this? And this is things that people skim quickly, right?
Oh.
In code, I take a while. I'm like, okay, this line of code I hear over here. And so they think, so people think, wow, the first thing they think, I mean, is this guy stupid, right? Because they're just like, why is he so slow? And then I think people appreciated that. I mean, that's the way I think, and I'm true to that. And I just... that's the way I understand it, and for some things it may help.
Interesting.
For some things it may hamper, right? For explaining it helps. So yeah, I think now I kind of warn people sometimes. Like when I want to have a conversation in math with somebody, I have to be like, okay, I just have to warn you, like I'm very slow. And I'm gonna ask a lot of dumb questions. Are you okay with that? and then we can talk and maybe understand things in different ways.
Cool. Yeah. That's interesting. This actually reminded me that my friends actually named me like a question bank, because I always used to ask a lot of questions in the classroom, no matter what other people think.
Yeah, that's good. That was the same, and I think that's wonderful because you question, right? Curiosity is very important.
Yeah, but later I used to realize that, those questions are lame.
No, but I think I've asked many lame questions and I'll continue asking them. And I think everything that's a piece of genius has ever started with a simple question. I think should not be afraid of asking questions and doubting things. I think that's the right way to learn. Yeah.
Yeah, and what is the one biggest problem and one problem in technology or life that you dream of solving?
Ooh, it's interesting. There's many. I think my lifelong one is I want to bring knowledge to everyone in the world. I want to bring education to everyone. And this is something that we have the technology to do for the first time. We are able to do that. So I want to bring quality education to every human in the world, regardless of where they are, how much money they have, what situation they are. I want to bring them the opportunity to be able to learn anything they want and be able to contribute to their community and to society.
Cool. And that is the same intention and the vision of the Serrano Academy as well.
That is, indeed.
And when you go for, getting into the project and understanding the machine learning requirement and everything, so at the end, you come up with a solution and you make it. But if it's like a project of the other person, like it's a client, where he's a business person, right? Understanding the domain is so much important to solve the problems using machine learning. That's all right. But how do you make the business person understand the complex workflows of your solution?
Yeah, that's a great question. I think when I have to help someone understand a machine learning concept, I try to think of really simple examples, and that can work in theory and in practice, right? Like if you have a recommender system, I can come up with a recommender system for 4 people, for 4 users, right?
Yeah.
And I can explain all the complexities with those 4 users, or maybe I need 10 users, I don't know, but I try to focus on the concepts, and I try to really solve the problem for a small case, because when you have computers, they can just do something in large scale. But if you're able to explain it if you're able to look at your problem in a very simple case and solve it there, you'll be able to scale, and then scale is very simple. So I always try to, in the practice and in the theory, I always try to look at an example.
Okay, so what do you think about the deep neural networks? So what they're actually communicating within inside, and how far we could hold the intuition within?
Yeah, I mean, neural networks are always going to be a puzzle for me. I feel like,
And you love puzzles, I know that.
and I love puzzles. Yeah, this one's gonna take a while. I mean, I think we are able to use them well. I think we are doing with neural networks like early humans were doing with fire. Like we can use it for cooking, and we know how to, we know that we burn if we touch it, but we know that if we cook with it, it's good, and then we manage them well. So with neural networks, we can use them very well, right? We're like, okay, try this, try that layer, try that architecture. But in the same way that early humans used fire, they didn't understand what was going on it, what kind of reaction was happening. I don't know if we fully understand neural networks, and this is my opinion. I mean, some people think, if we know the formulas and the math, we understand them. I still don't fully understand what happens inside, right?
Cool.
But in my head, like if you have, for example, your data is you have two inputs, right? So your data is two variables. Then you're living in the plane.
Yeah.
And if your first hidden layer has 3 nodes, then you're kind of putting that plane living in 3 dimensions, right?
Yeah.
And then you're doing some transformations, and the transformations can be like, rotation, translation, scaling, and then you do some kind of sigmoid or tanh, which is kind of blends it, or like it's just kind of folds it, right?
Yeah.
And then, or if it's a ReLU, it just kind of cuts it, breaks it, and puts angles on it. But then you do that repeatedly, right? Like you take your little plane of data and you put it in 3 space and fold it, and then you put it in 10 space if you have 10 layers in the next 10 nodes in the next layer, and then you bring it down, and then you fold it and fold it and unfold it, and then at the end you end up with something that has all your labeled ones, your positive examples on one side and all the zeros on the other side. So it's a bit of that.
Yeah.
And I think being able to understand that would be fascinating, and I think maybe one day we will, and it'll be super easy, and then kids will learn it in kindergarten. But until then, I mean, I think we should. Yeah, I think there's a lot of research going on. You can look. There's research looking at what happens in the layers, clustering things in the layers and just understanding them. And I mean, in vision, you can see it, right? You can see that what each layer sees is different. If in the first layers of a neural network, you see points and lines, and then you start seeing, like little eyes and noses, and then at the end you start seeing faces, and you just kind of like, I'm not sure why. I'm not sure why that happens, and understanding that would be fascinating.
Totally. And I have this question for you where you have to be seriously vulnerable about it. What is the high impact risk that you have taken till now?
Interesting. I mean, I've taken, I've been very blessed. I've had opportunities, and I can't complain. I have taken some risks. I never planned to take them, but things kind of worked out that way. Switching careers late in life several times has been a risk. The first time when I left mathematics and went to technology, it's a big risk. I didn't know, like people were much younger than me. Like I had it was just could have gone well or maybe not. So I did that, and it paid off the first time, even though there were like some successes and some failures. So it paid off. So I kind of enjoyed it, and so I do take random risks in career, like just switching completely. So when I decided to switch to quantum, I felt like it was, if I had done one big switch already before, or 2 big switches, it made sense, right? Like switching from coding to education. Like I've enjoyed those, and I know they're risky, but they've paid off, and I've really been able to learn a lot in the process.
It's kind of really, it shows how you think when you had that thing as a teaching profession, and you really love your passion, and you move for the production, for the product development into the companies, and then you're switching your careers. That actually shows how you are exploring various things that you're fascinated about. It's really amazing, Luis.
Yeah. Yeah, I mean, I feel like I look at the path, and sometimes I feel guilty that I didn't stay in one thing, and sometimes people are just much more experts. But then I tell myself the same advice I tell others, right? Like, do your own path, and I'm like, okay, maybe my own path is just bounce around everywhere and pick up a few things from here and there. So I enjoy it, certainly enjoy it. Yeah.
And how I feels in how I feel when it comes to being on a certain thing for a long time, or you be explore on whatever you wish. So what I personally feel is into me, and this is my personal thing. So how I feel is that we have only one single life, and you're gonna explore what you wish. That's it. So that is how I feel.
I love it. Yeah.
Perfect. And I don't know whether you stopped off for a moment and thought about your learning style and recognized that the approach that made you better. All right. So as everyone in the school, they read differently, they write differently, they speak differently, and just in the same way, they think differently. And guess what? They learn differently as well, right? So in the same way, how do you program your brain before you learn something new? And what is your learning style?
Yeah, I mean, yeah, as I said, yeah, my learning style definitely comes from my slow way to understand things, and so I embrace it. I go. This is something actually I learned from my PhD advisor, was to stay at the beginning and actually sort of have respect for things that for others that are simple. Like, many people skim over the details and they pass the page one of the book and they pass page one of the paper and they start reading later on. I get stuck in the beginning.
Yeah, I used to do that.
Yeah, I used to do that, but now I don't mind. I have respect for the first sentence and the first page. Like, I just have, because there's a lot there. There's a lot of beauty in simplicity.
Yeah.
In the same way, like, in an atom, there's in a grain of sand, there's so many atoms and there's so many things, and it's a universe, right? In the same way, in the simple concepts can be much understood much better. So when I try to understand something new, I mean, I start reading the literature, and I don't mind going from the very beginning and just, as I usually do, try everything in an example, right? So I'll give you an example. I've been trying to understand RBMs. There's a video coming up soon. But I try for those, and I look at papers, and I look at Wikipedia, and I try to build one myself. I sometimes try to code it, or at least work out an example of something with 2 nodes or 3 nodes, work out all the formulas and try everything that's until it starts clicking. And I think I always try to explain it to a 5-year-old. The moment I can do that, I'm done. So yeah, it's not a linear process, but the most important thing is that I enjoy being in the process of not understanding it yet. I'm like, okay, I need to understand it.
Totally. And what are those often mistakes that you find young data science aspirants usually do that? Okay.
Yeah, I think if you're hungry for understanding, it's a good thing. We tend to sort of negotiate with ourselves. Like, we tend to look at the formula and say, oh, okay, I get the formula. But that doesn't mean we get it completely. Like, the fact that we understand that this is a summation and that this is a sigmoid and that this is that doesn't mean we understand why it's happening, right?
Yeah.
So people tend to focus on the formulas too much without looking at the big picture. And the same thing with code. We tend to look at the code and be like, okay, if I can code this, I'm done. But I like to look behind. I'll give you an example. When I look at an error function, right? It's, for example, it's a sum of logarithms. Why is there a sum of logarithms, right? Like, people understand a sum of logarithms, right? Just go, and many times they understand, okay, this error function is big when my model is bad because it's a lot of error, and the error function is small when the model is good.
Yeah,
that's good. That's a level of understanding, but still not clear why it's a sum of logarithms, right? Like, why isn't a sum of sine and cosines? Like, why is it logarithms, right? And then one thing to look at that is, okay, a sum of logarithms is a logarithm of a product.
Yeah.
So maybe the point of logarithm is that it turns sums into products, or products into sums. So what is that product? It's a product of things. And when you look at the product, it's always things that are between 0 and 1.
Yeah.
What are things that are between 0 and 1? Probabilities.
Perfect, yes.
Right? And so all of a sudden your sum of logarithms, forget the logarithm, it's a product of probabilities, and a product of probabilities is a probability itself, right? And all you have to ask is, what is this the probability of?
Yeah.
And the moment you decide, okay, this is the probability that something happened. Okay, then I understand that error function much better. Now it's no longer a sum of logarithms. Now it's an event that happened, and I just calculated the probability, and that can be high or low depending if my model is good or bad.
Yeah.
Right. So if we stop at the sum of logarithms, we're doing ourselves a disservice, right? Because we're never gonna fully understand what it means, and we're gonna use it, but it's good to go deeper. So I think if people go deeper and not necessarily in the math, in the conceptual things, right?
Yeah.
Yeah, I think that's something that can help us do better models.
Cool. And when we try to understand this machine learning models, not only that, but also any of these mathematical theories or proof, anything of there. So people used to go and they look at that and they try to look at the formulas and they think that they understood what, as I said you earlier.
Yeah.
Right. But, when they come to know about, this is not the way, right? So if I wanted to get the intuition, so they have to unlearn it first and they need to relearn it in a different dimension.
Yes.
Right. So, it's actually funny that we always excited to know more about the things, but we forget to think about learning how to learn.
Yes.
Right. So what do you say about it? How can someone figure out a learning approach that they could put in execution for learning something new in a better way that could make even more sense, even more execution, even more productivity?
Yeah, definitely. This is something that I learned at Udacity, both from the students and from my fellow teachers. I noticed that we had different ways of learning things, because we're always learning things. Well, we have to teach, we have to learn first.
Yeah.
And there were three types of us, three main types. There were the ones who really like to work out the math details. I had friends who said, until I work out the entire board of backpropagation, I don't get backpropagation, right? There were others that like to build things. So they were like, okay, I need to open a notebook, build this model, put some data, look at the results, and when I build it, then I understand it. And then there was the people like me who were like, I have to take a napkin and explain it in a crayon to a 5-year-old. And that's when I get it. So conceptual, right? So we realized that none of them was better. There were three points in a triangle, right? Like building, working out the math, building things, and understanding concepts. And so we started focusing our teaching like that. And we noticed that students were like that too. Some of the students were, they just wanted to do the lab. Some others, they just wanted to do this formulas. And some of the, like it's. I think those are three. There may be more, and obviously there are things between them. But identifying which one you are is very good, because you can focus on that one and not forget the other two. Right? There's times where I'm like, okay, I need to code this, even though I'm not a coding understander, but I need to code this to fully get certain things. So not forget the other two, but embrace the one you have and use that one to your advantage. That's how I think you can learn.
Perfect. And also, I know you're fascinated about solving puzzles as well, along with the mathematics. So how about sometimes when you try solving mathematical puzzles, we feel blocked,
yes.
Right? We feel a lot of times, like when you couldn't able to make it, we feel blocked, right? What do you do when we get a puzzles that you couldn't solve? So because I get it in the mind and I couldn't able to think about anything. I think about the puzzle, how could I do that? How could I make it? How could I crack it?
Yeah.
So what do you do then?
Well, yeah, I mean, the first thing I think is enjoying it. Like, does it happen to you that you solve a puzzle and then you kind of remember, oh, it was so much fun when I didn't know the answer and I was kind of solving. Like sometimes you want to forget it and do it again a year later or something.
Yeah.
So like you appreciating that moment when you were lost and saying, I missed that moment. Then when I'm solving a problem, I think, I am in that moment. Like the me from the future is going to be jealous of the me from now.
Oh my God.
Because the me from now is having fun solving the problem. The me from the future knows the answer and that's lame, right? So I appreciate that. And if it takes me a long time, I make sure that that removes some frustration, right? Because there's frustration when you're not yet solve the puzzle, right? So I try. That's my first step to trick myself into enjoying the frustration, and then I just sometimes I stop and come back with a fresh mind, Sometimes I go for a walk. I come back. I try different things. I try to have different approaches. Yeah, just sometimes there's like a hard work way to solve it. Like there's something that may help you, but it takes a lot of work. You just kind of sometimes you have to push through. so trying to remember that. But I think the most important thing is enjoying and appreciating that moment.
Cool. And how do you keep your thinking that could actually improve your performance in solving puzzles and also in real world problems?
Yeah, I mean, I think that's like a sport. It's a skill. For example, the Math Olympiad problems that I used to solve in high school, I can't solve them anymore. I have a hard time. Like sometimes I sit down and try to solve those particular problems, but it's a skill, right? It's like when an athlete stops doing it and they know exactly what they have to do, but their muscle memory is gone, right? So it's something you need to constantly be doing, something that you need to constantly be practicing. And if you enjoy it, it feels like you're doing it for fun. Like when you play a sport for fun, it's like,
yeah,
so I think it's something you just need. All you need is just consistency and keep doing it.
Cool. And I have this question for you, where all the researchers, not only in data science, no matter where they are, so they'll be surely liking this question. So how to understand a research paper better?
Yeah, that's hard. Papers are so hard to read. It's incredible. I mean, I don't know. I don't think there's anybody who maybe there is, and I congratulate them, but I'd be surprised if somebody comes and tells me, oh yeah, no, right, papers are just so easy to read. And I don't know if you had this experience. Like you talk to sometimes you meet the writer of the paper and you spend time with them and you go, okay, help me out here. And then they explain it to you the way they understand it, and it's so much simpler because they have an example in mind or something. And I'm like, oh, why didn't you say that? But at the same time, it's hard to write papers. They have to be done in a certain formal way that are even the ones I write. Like I have to like write them in a sort of formal way, and then years later I don't understand my own paper. But I try to see what they were thinking. I try to understand what the writer was thinking when they wrote the paper. And this is something that I've been challenged lately because I have to read a lot of papers for my current work. Since I tend to go for the details and I tend to stay on the introduction or in the abstract for hours or something, that helps. But I've actually learned something from my colleagues recently, which is that you can also do the opposite. Like you can also read it like the way a bird sees the forest, right? You don't have to go for every tree and every piece of grass, and you just look at it from the top and be like, okay, they did this, then they did that, then they use this function that I don't know exactly how that works, but it does this, and the results are that. And I find that that's a good skill too. Like I think you can skim through the entire paper and try to see what they do in large scale without understanding the details. That can be one copy of you, and the other copy of you tries to understand the details carefully. That may be a good way. But I'm still struggling. I think if I figure out how to read papers, I'll let you know. And if you ever figure it out or somebody tells you, please let me know. Okay, like you just feel like immediately like, Luis, I figured out this is what you have to do, because it's hard. Yeah.
Okay, so I could tell you a little of my experience here. So I never completed reading a paper totally, all right. So, but I got a chance to work at research and development centers of a company where I was interning there. So the R&D team working on machine learning and data science. So they are specifically, work on reading the papers and then implementing the papers. To be very precise, they try to implement the papers in the real time. All right. So, what I learned from them is that they keep track of everything. Okay, whatever they find something interesting out there. So they use some tool called Zotero.
Okay,
Zotero is a application. So they have this within themselves, and they keep track of everything what they found out something interesting. They keep track of all of that because we see the words often coming up many times in the paper, right? Yeah. And we think about the same thing. What was that word? Okay, I didn't know that because this is the 21st day that I'm reading the same paper, right?
Yeah.
So That's how they keep track of that, and they make a point of it. And what they do, they rewrite the paper.
That's wonderful.
I mean, that single paper could turn up into 10 papers.
No, I love that. I love that because many times, yeah, you're right. Many times you want to know what failed, right? Like if they tried 100 things and they only tell me the one that worked. That's like, tell me the story. Like tell me the ones that what you tried, what failed, what you learned from each one of them. I think there's a lot more that can be said. So it's great. That tool sounds great. Yeah.
Cool, perfect. That's really, really amazing conversation. These are the things what I really personally wanted to ask you from the podcast. 3 days ago, where I requested you to make a AMA, like ask me anything with a BATLY URL Google form where people turned up to ask you a lot of questions. But I took out a little specific questions for you, which are kind of related to our podcast. Okay. So these are the things what I had further for you. So the first question is, it's regarding the deployment and all. So what are some pitfalls and best practices of deploying and running AI ML models in production for enterprise strength applications?
Ooh, that's interesting. Yeah, it's a good question. It's difficult because there's just too many things that can happen in production, right? So I'll deviate from standard technical things, and I'll say like the most important thing is to pick your battles, right? Like to know exactly what you need to do and what you don't need to do, right? So know your application well and your problem and your users well, and then decide, okay, I want to optimize on the following and not on these other things. And that will help you, because a common thing that happens is you start solving one problem and end up solving a different one. So just kind of pick your battles and know your problem well.
Cool. I hope that answers his question or her question. It's totally fine.
I hope so.
Yeah. So possibly. So there is another question for you. Hey Luis, I have a theoretical background for machine learning, but while practically performing a task, it's really hard to choose a correct model. So how swiftly to choose a model and obtain high accuracy? So high accuracy is the metric they use here. So make sure to be on it. Okay.
Yeah, picking models is hard because they're all very different, and there's very few times that I see a problem and I go, ooh, that's definitely this model problem. Like the many times you want to pick a few different ones, right? So so for example, if I have a decision trees or SVM or neural networks, like I just try all of them, right? And the point is to know how to compare them well. So if you want accuracy, first of all, ask yourself the question, do you want accuracy or do you want something else? Because it could be that what you want is precision, or it could be that what you want is recall, or some kind of score, F1 score in between. So that is an important thing. What do you really want to optimize? And I do a lot of grid search. I do a lot of just picking a bunch of different models and a bunch of different hyperparameters and training all of them and seeing which one did better. There's no shame in that, because models are a bit of a black box. Even if we understand them well, they're a bit of a black box. So just know how to compare them well. I think that's a better skill than knowing how to pick. Just know how to compare.
So making those black boxes, to be clear and transparent, is the whole game. So, and also here is another question. So do I need to go to post-graduation school in order to be a great data scientist or a machine learning engineer? Or should I get experience working as a data scientist with a computer science degree and learning as I go?
Yeah, I mean, this is something I like to emphasize. You absolutely do not need postgraduate work to do well in data science. If you want, it's great. If you want, it's a lot of fun. If you want to do a master's, if you want to do a PhD, you get to learn many things. It's very interesting, but you don't have to. So things that work, as alternates, online education is very important. I've taken many courses online, things like Kaggle competitions, or anywhere you can get your hands on data and play with it, and experience. If you can do an internship, if you can do work here, work there, freelance, if you work like that all gives you experience, because in interviews they put scenarios on you and they say, how would you do with this model? So all that experience is what works. And sharing knowledge, I mean, writing blogs, making videos, that's always important. I think everybody has something to say, so I always recommend to do that as well, and it helps your brand, right? Like if you go in an interview and they see your blog and then they read it and then something's awesome, that's super helpful. So yeah, just a combination of things makes it's not necessary to have postgraduate.
Perfect. Okay. So what do you think is the best way to get motivated? Okay, when you are feeling down and didn't find excitement in the projects that you have been working on for long, so how do you get motivated for the work? I have been through that. Okay, I'm really curious for the answer.
Oh yeah, yeah, I've been through that many times. I think there are two kinds of lack of motivation, and I've certainly had both of them. There's the small scale and the large scale. The small scale, I go through it every day. It's sort of like when you're tired of what you're doing, or like how do you push through if it's something you're doing and you like. And I think you have to take care of yourself. We tend to work many hours. Now with these days we're in front of the computer all the time. It's always good to take breaks, to rest, to develop other things, do other activities, friends, family, like just other things that keep your mind off are important, because when we stay too long on these things, even if we like them, they can be very difficult. So don't forget about yourself, your body and your mind. So that's the small scale, right?
Yeah.
There's also the large scale, the large scale lack of motivation, which is I don't want to be doing this, and that happens. And sometimes society pressures us to want to force ourselves to love what we do, but maybe we don't. Maybe it's something else, I think when that happens, you have to go deep in, and we have to be honest with ourselves, true to ourselves, and say, okay, do I love what I'm doing, or do I hate it?
Yeah.
And that then you have to take measures, right? It's hard, right? You may be in a situation where you depend on your job or things like that, but it's always, you can always question, right? So the question that I like to ask myself all the time, that was once asked to me, is what would you do if all the jobs paid the same and there's something in your mind and that's your passion? So that was once asked to me, and I was like, when I was a programmer, and I was like, teaching.
Oh my god.
So I was like, I definitely have to be a teacher. Like you know what I mean? Like, so you have to ask yourself that question every day. Like, am I, and if you don't have the passion, if it's not clear what the passion is, then don't worry. Keep looking for it. Keep trying to find what you like. But I think the key to extreme motivation is finding that thing you love to do, and doing it. So it depends on what kind of a motivation you're having. Like, that's, you can take either small or large measures.
Absolutely. That literally blown my mind. Think what you said. Imagine all the salaries or all the payments where you have the same, and you choose the one thing that came into your mind. That's amazing. That's really, really
Exactly.
amazing.
And it's always, yeah.
Cool, because we've been biased with this. We've been totally biased with all the income that we get for a specific position.
Yeah.
Not realizing that we are forgetting our deep roots with the purpose and the passion, right? It's amazing. That's beautifully said, Lewis. Amazing.
Yep. Absolutely. We go for income, for status. Yeah, exactly.
Yeah. Cool. And here's another question for you. So, do you have any advice on how to land a good company to work on artificial intelligence, subfields like computer vision, data science, reinforcement learning, etc.? So, as a recent undergraduate.
Yeah, definitely. There are ways. One thing is very important is referrals. I always, you can never. I always overemphasize referrals, because if you have friends that work on something, that helps a lot. They give you a referral in the company, and that goes much farther. So don't be afraid to contact your friends. They do like to give referrals, because not only they get to maybe work with you, but they also companies pay sometimes for referrals. So don't be afraid to contact people that you know.
Yeah.
Internships are very important. If you can get an internship, that'll get you the foot in the door. Other than that, just throwing yourself out there. I think, just keep applying, keep knocking doors, And many times you can enter a company for something slightly different, but if the company has something, if it's a big company and you want to do RL, but you end up doing something different, just go inside and try to look at internal transfers. Internal transfers are easier than coming into a company. Many little things like that.
Totally. But I think this question would also possibly make the listeners to have another question in their mind. So what it would be like, how about your personal journey jumping into Google and from Apple and from to Udacity? So how was your approaches getting into them?
Yeah, great question. For Google, I was a referral. I asked a friend when I was switching into industry. I didn't really know what I wanted or what was there. I just knew that I was leaving academia. And so I started different things. I talked to people in finance, I talked to people in consulting, and I interviewed here and there. And so I started contacting all my friends, basically people that I knew, and going to conferences and just asking for cards, and just talking to people. And that's how I came to tech. I wasn't thinking about going to technology at all. And a friend told me, hey, come to Google. I work at Google. And I'm like, well, I know I don't program that much. And he's like, no, I didn't either, but it's more about they look at other skills. And so that's how I got involved. And then then they gave me a referral. My friend gave me a referral, and that got my foot in the door. Once you get your foot in the door, then it's easier. Once I was at Google, I knew people here and there. So when I decided to move to Udacity, is when I decided that I wanted to teach. And then I just applied out of the blue. Other times, sometimes they contact my YouTube channel has been very, very helpful for places to contact me. So I always tell people, share your thoughts, write a blog if you like it, make videos, because then people contact you from that. Like Apple contacted me because of the YouTube channel.
Cool.
So yeah, always like that. And for quantum, I have a very good friend who's a quantum research scientist, and I started asking him so many questions about quantum computing.
Okay.
That he one day said, do you want to work on this?
Absolutely.
And then he referred me, and then I switched. So it's just asking. My habit of asking many simple questions got me there, and so a referral was what got me there.
Amazing. So that's really, really great. So that says me to be like, no matter how you knock the door, but you keep knocking it.
Always.
Right? That's totally important. But if you quit knocking, you keep stopping yourself, right? You got to keep knocking the doors.
Exactly.
Totally. Cool.
You got to keep knocking. The worst that can happen is that you don't get a reply, and I have probably thousands of not replies.
Yeah, I know the pain.
One reply wins over 1,000 non-replies.
All right, so here you have another question. Have you ever failed?
Oh my God.
Why not? Yeah. If so, how did you manage it, and how did you use that experience?
Have I failed? Failed so many times. I have failed many times, and I'm very thankful because that has taken me to where I am. My first failure was in academia. I mean, I couldn't get a job as a professor, right? That was my first one. I went all the way to postdoctoral fellow, and then it was hard to get a job.
Oh.
So I was devastated. I was frustrated. And that's where I started looking for other things. And thank God, because I started looking for other things, and I got to where I am, right? And so after knocking many doors, because, I was getting interviews, but not jobs, and it was very frustrating. Somehow Google worked. Somehow many companies said no, but Google said yes. And I ended up at Google, and that was another failure. I didn't do very well there. I was coding this production code, and I was not really a coder. So I was I learned a lot, and I enjoyed it, but I was certainly I was struggling, right? I enjoyed the machine learning part. I enjoyed the data analytics part, but it was just hard production code was so difficult for me. And so that's when I started looking, and that's where actually the question was posed to me, like, what would you do if all the jobs paid the same? And I was like, I wouldn't be writing production code. I respect those who do, and I think I learned a lot, and I have great respect for those who do, but I was not that. I like to write code, I like to do things, but not And so yeah, that after that wasn't going well, I was also I was also very devastated, because I was like, I tried one career and it didn't work, and I tried something else and I didn't, and but after those failures, that's what got me to teaching. And I'm very thankful for that. I think if I was a little better at those other things, I would have never discovered my passion for teaching. So I'm glad that those failures happened. At the moment, they're very depressing, and you can feel terrible about yourself because your self-confidence can go in the ground, and it's very hard. But if you sort of fast forward and know that help you find your true path, then you can be very thankful. So my advice for anybody who's in that is like, I hope it doesn't sound naive, but let me say like that may be a door. Like failure may be a door to greater things. And so just push through, trying to find what you really love, and that's, I think, the only way to overcome it.
Yeah.
And be ready for more. I mean, I'm ready for more failure. I think if in the future I try something and I and I fail completely, that's okay. I think you should have a rate of 50% maybe, success and failure. If you have too much success, it's like maybe you're just not trying to find hard problems, right? Like you're overfitting.
As you say again, this is a sport again. So you fail as many times, but it's not like a gambler's fallacy that you have equal number of winnings and also equal number of failures. No way.
Exactly.
Totally. Okay. So here you have another technical question this time. All right. So how can we build a recommendation system without a rating column, assuming that we have user ID, video, and the video genre?
That's a good question. You can't with user ID, video, and video genre. If you don't have a rating, I would look for other signals, right? Like there's many signals you can recommend on. If you have any kind of number of clicks or number of watches or things like that, time they spent on the page or on the video or on the song, like how much money they spent. If you have any kind of signal like that, then use that instead of rating. But if you still don't, then the only things you can do are unsupervised learning, because you don't have the label, right? So you can do unsupervised learning, you can cluster. So if you cluster your users and look at the videos they watched, you can see that if, for example, a certain cluster watched all these videos, right? So you can recommend to a user in that cluster, the similar videos. So you can do dimensionality reduction and clustering can help you a lot. Matrix factorization can also help you a lot. So if you put a matrix, I have a video on that in case they want to look at it, where they do recommendations there, but it's not with rating, right? You just put the users and the videos and a big matrix of what they watched, and try to factor that matrix, and that tells you what things are likely to watch, that they're gonna watch. Let me even go simpler answer than that. If you don't have a rating column, but you have who watched what, you can recommend over that, right? Because you have user ID, video, and video genre, but you also have what videos users watch. If you have that, just recommend over that, right? Over like trying to predict what video somebody watched. Yeah, so you have a lot of information there.
Yeah, awesome. So we are almost on the edge and we are about to go to the end. So here is your last question. So is there a relationship between dynamic systems and machine learning that is not touched upon very much in the literature?
Yeah, that's a great question. Yeah, definitely there's a lot of dynamical systems and physics and machine learning that I haven't seen, that people talk about, but I haven't really seen them that much in the literature. The way physicists think about machine learning is actually fascinating, because when you think of machine learning, many times the algorithm is it's increasing the probability of something, right? Or decreasing the error function, decreasing the loss function. When physicists look at it, they look at decreasing the energy, because they connect the error function with entropy and with energy, and somehow increasing a probability is decreasing the energy, because states with low energy are more likely to appear.
Cool.
Right? And that's why in physics, things tend to cool down or things tend to fall. Like things just tend to try to go to their minimum state of energy in the same way that models try to train. And so there's a lot of that. And every time I talk to a physicist, I just try to pick their brain on this, and but yeah, I mean, I think there's a lot more connections that we think of.
Awesome. I never expected that there is a lot of correlation with this machine learning maths and also the physics. Cool. I really got to know about this.
Yeah.
Amazing.
Thank you.
All right. So we are on the end. So thank you so much for joining us, Luis. I'll be adding about the book giveaway. So we have 5 free ebooks to give away to our listeners now. So who can make it till the end, and also looking at the description perfectly. So you can reach me out, and the position I'll be mentioning in the description. So we have 5 free books away giving out from Luis. Thank you so much, Luis. Thank you so much for that.
Thank you. I also like to remind the viewers that there is a code for a 40% discount that Manning editors, the editors of my book, have very kindly given to us, as well as the 5 free ebooks. What they have to do is they go to the link that you give them for the page.
Absolutely.
For the page of the book, and then the code is PodExploit20, which you're also gonna write down. So thank you for that.
Awesome. So thank you so much, Luis. I'll be highly recommended to go check out the Grokking Machine Learning book, and you apply this thing if you're out of this 5 copies first. Okay.
Thank you.
So perfectly, it will be available for the lifetime. So go check it out. PodExploit20.
Yes.
Thank you so much, Luis. It's really an amazing conversation with you, and thank you so much for your time. I never expected that you will be in the show. Thank you so much for this.
Thank you, Teja.
It really means a lot to me.
Thank you for having me on your show, Teja. It's been wonderful to talk to you. It's been an honor, and thank you for your invitation.